All right, today's work we are going to be looking at the relationship between voltage, current, and resistance. So you're going to be using the simulator that you've been using for the last couple of days. So you're going to eventually go to simbucket.com and use the same kind of setup, except this time you're going to be looking at the specifics of the relationship between voltage, current, and resistance. So you should have this lab in front of you now. Hopefully the teacher has given this to you, and this is the lab that you're going to use to record your information and then go through the follow-up questions after getting your data from the simulator. So just to quickly review, we're going to be looking at voltage in this lab. And remember that voltage is that potential energy. It's that energy that's attached to each charge. And so the voltage in this case is always going to be generated by the battery source. And so we know that, the more voltage that's present, the more energy that's going to be going around the actual circuit. The second thing that you're going to be measuring is current. And current, again, is that lump sum of electrons that are moving around. It's measured in coulombs. So remember that when you have that 1 amp of charge, or rather 1 amp of current, that's equal to 1 coulomb of charge, which is really equivalent to that 6.24 times 10 to the 18 electrons. So those are the two things you're going to be measuring in the lab, which is no different than looking at the parallel and the series circuit lab that you did the last couple of days. What you're going to be looking at in this particular lab is the relationship between voltage and current. And that's going to be dictated by what we call resistance. And resistance is what impedes the flow of electricity in a circuit. So again, think of a hose, and if you crimp the hose and water's flowing through it, less water can flow through, and that's really what resistance is in a circuit. It's just either a load or the type of material you have present in the circuit itself that impedes or slows down the actual flow of the electrons moving through the circuit. So there's really less of the ability of moving energy throughout the circuit because you have less current to be able to move it. So remember that current was the trucks that we used as our examples, and as the trucks moved around, it delivered that energy to the different loads. So in this case, when we look at resistance, we're really changing the amount of current and really changing the amount of trucks that can actually move around a particular circuit. Now, to do this lab, you're going to set things up in a very, very simple circuit. So I'm just going to draw in this little lab outline what you're going to create on your simulator. So you're going to have a battery, and you are going to change the voltages of that battery as you go through the circuit, but you're going to set it up with a battery, and I'll show you in a few minutes what the voltages you're going to use. You're going to connect that to a resistor, and then that's going to come back to the battery. Very, very simple circuit. And what you're going to do in this lab is you will measure the voltage across the battery, which is going to be V0, which is total voltage, and then you will also measure the voltage across the resistor, which will be V1. So the resistor is always V1, the battery is always going to be V0. You're also going to measure the current that's flowing through the circuit, and that is going to be I1. So remember, we measure current with an ammeter. That's why we use A. We put it in series, and we're going to measure the flow of current through the circuit, and then that is going to be really the equivalent to I1. Now, in this lab, what you're going to do is you're going to choose 3 different resistor levels. So that resistor level is totally up to you, right? But you will change 3 different resistors. So you're going to make really 3 different circuits. And then what you will do is you will measure the current and the voltage that goes across that resistor. And you're going to change the voltage as you move through. So, just for an example, and just to kind of clarify what's going on. So for the first one, what you'll do, and then I'll just erase this, is, say for an example, we are going to choose a resistor that is, say, 20 ohms. Now, 20 ohms is the unit for resistance. So say you choose 20 ohms of resistance. So you're going to, in your circuit diagram or in your simulator, you're going to put a resistor in there, and then you're going to modify that to 20 ohms. Then you will change your battery, and for example, you might make it, say, 3 volts. So you set it at 20, and then you're going to make it 3 volts. So then you'll measure the voltage across the resistor. You'll measure voltage across the battery. Remember, that's going to be, the battery's V0, resistor's V1. And then you will also measure the current, which is going to be I1. Once you've done that, and you've measured that, you're going to record it into the table, which I'll show you in a minute. Then what you'll do is you'll change. The only thing you're going to change, you're going to keep the same 20 ohms of resistance, and then you're going to change that, say, to 6 volts, and do the same measurements. You're going to measure V0, V1, I1. Once you've done that, then you're going to change it to another voltage. So say it's 9 volts. And then you will measure your total voltage, your voltage across 1, and then I1. Once you've done that, and you've changed the voltage 3 times, then you will move to a new resistor. So in this case, you'll move, say, from 20, and say you choose 50 ohms of resistance. And then you're going to go through the exactly same sequence again. And so you would then measure, say, 3 volts, and then you would measure 6 volts, and then 9 volts. And then once you finish that, then you're going to move to a new resistor. And then you will measure that then 3 times, right, with the 3 different voltages. So the sequence is the same for each circuit. The only thing that's changing is the amount of resistance you're providing for each circuit. So in this particular example, my first circuit had 20 ohms, and then I recorded data with 3 volts, 6 volts, then 9 volts. And then for my second circuit, all I'm changing is I'm changing it to a 50 ohm resistor. Then I'm measuring 3 volts, 6 volts, 9 volts. Same thing for the third one. Start off, I might change it to, say, 100 ohms. Then I'm going to measure 6 volts, or sorry, 3 volts, 6 volts, and then 9 volts. Right? Same sequence. So in this area where it just says, you know, the circuit diagram, again, the basic circuit diagram is just making your battery and your resistor going back to the battery. And then that's going to be your basic diagram. And again, you're going to be changing your voltage and then changing your resistor. Now, all that information gets recorded in the data table on the back of your page. So you're going to just flip your page over. You're going to see where you record that data. So, for example, say my first resistor level in my example was 20. So that's 20 ohms of resistance. And then when I go through the simulator, I'm going to, set the first battery setting at 3, and then I'll measure my total. And we know from our lab that that's going to be 3, and then this is going to be 3. And then I would measure my current, again, with my ammeter, but it's called I1. And then I would record that information in amps in that box. Then I would move to 4.5 volts. And I would do the same thing. Now, I think in the simulator, you can't go up by 0.5. So, again, you can change that to whatever you want. So if you want to make that 6 volts and then move the next one up to 10 volts, that's fine. But I'm pretty sure that you can't go to 4.5. So just choose something reasonable and then keep that same sequence. So if you choose to go from 3 to 6 to 9, then make sure you go 3, 6 to 9 for each of your resistors. So you'll go and say I change that to 6, and then I say I change this to 9. I'm going to record that information in my chart. So I'm going to fill out this information. And then once I finish with that particular circuit, then I'm going to move into my next resistor. And again, I can choose whatever I want. So I might say choose 50 ohms resistance. And then I would make this 3, 6, 9, because I want to keep the same sequence as I did before. And then again, fill out the data as I go through it. And then I would move to my next resistor, change that up, might make it 100 ohms. Again, that's up to you. But again, whatever you choose for your voltage, you want to make sure you keep it the same. So in this case, I would make it 3, 6, and 9, and fill out my data. Once I have my data filled out, then I'm going to do this calculation, which is really going to calculate the relationship between voltage and current, which is really resistance. And so I'm going to take my V1 and my I1, and I'm going to divide them, and then that's going to give me a resistance level on that calculation. And so then you would finish calculating all that information all the way down the chart. Once you have that all completed, once you have your data table, then there is a series of questions that you need to go through. So the first thing, your first task, is to graph your information. So you're going to plot on graph paper, and the teacher should have some graph paper now. You're going to plot voltage and current data for each resistor. Voltage will be on your y-axis, and current will be on your x-axis. So you will have voltage and then current along your x. So voltage on your y, current on your x. And you're going to plot your information, and I want you to plot it so you will have really 3 different lines, and each line is going to represent the resistor you used. So this might be, resistor 1, and this might be resistor 2, and this is resistor 3. Each line will have 3 points to make it, and so you're going to plot all your data on the same graph. So you'll end up with 3 lines. Again, make sure you properly format your graph, title, figure number, make sure your x and y axes are labeled properly with the correct units. Once you finish the graph, because you need to do the graph first, then you can complete task 3, which is the analysis questions. And you'll go through that information, and then you're going to answer those questions according to the data that you have from your lab. This should take probably most of the period, and then what you don't get done, you'll have a little bit of time on Wednesday to finish it up. But this lab will definitely be collected on Wednesday. All right, so I hope that clarifies what you have to do for your lab. And yeah, again, make sure you're taking careful data, make sure you're doing all your calculations correctly, and make sure you're graphing your information to represent those 3 different resistors.